Okay. Now we have to close right on time. I have just 2 minutes for some remarks for closing. As the point of view of a doctor, of an oncologist, not a scientist, etc., and two recommendations for the future. First is invest, increase, and support research. This is really fundamental. Today, oncology is in the era of precision oncology. Precision oncology means to know all the characteristics of the patient and all the characteristics of the disease. That means that we need to have a lot of information, multi-data, in terms of clinic, in terms of biology, molecular profilation, genomics, transcriptomics, and so on. This is very useful, and we have the great opportunity to use very sophisticated artificial intelligence tools in order to select properly the patient for hadron therapy. This is really a request. The second need, the second recommendation is absolutely to increase the accessibility of patient to hadron therapy. I believe that less than 1% of the patient that who receive radiation therapy in general who receive hadron therapy is a very, very low an unacceptable number. I don't know the solution. I don't believe that is only a problem of cost, but of course, any effort has to be produced in order to favor this point, especially the area in which we are a concentration of center, limited number, but concentrated, and other area in which we have seen that there are nothing. This really is important. And we have new challenges for the future that are in favor of the development of hadron therapy. For example, the increase of incidence in cancer that has been already shown in one of the last slides. This is absolutely true. We have an increased number of cancer, but usually we consider the cancer related to the elderly. Simply is not true. Last data means 3-4 years ago, since to yesterday, is that we have a very, very important increasing in cancer incidence in young people. Young means less than 50, but means also very young people and adolescent. And this can benefit a lot of this type of radiation. Just a short message, we have no more time, and we have the round table after that can clarify, and I hope also to discuss this point. Thank you very much for your attention. The next, there are moderators, Sotirios and Sandro, and two other panelists that for you. Do you want to sit there with you, or you can sit there? So I think Mimosa. You're gonna come here, maybe?
See how the present
turning back on my
Maybe if it's not proper to sit there, you could come here. That's not problem. Please have a seat here. Okay.
Give me a second. Thank you. Okay, camera is on. And you can
Okay,
start.
guys, don't go away. Anyway, with pleasure, we will have a nice roundtable discussion here. And I'm honored to have as co-moderator my friend Sandro. And we have very important contributions. First of all, by Mimosa from the University of Skopje. I'm sure the presentation by Mimosa will be very interesting because it has to do with the cancer incidence in Southeast European countries. And we have also two distinguished colleagues, Maurizio and Semi, as panelists. We hope to exhaust all the, to be able to reply to all questions that will arise during the meeting. Please feel free to, shoot us. So,
Okay.
Mimosa, please go ahead.
Thank you. This is about the cross section of the Balkans, of the seized countries. How far is the cancer scene? How far we have made the research, and how are the results of our research on the cancer scene established by the research done at CERN with me and Manjit and other members of the team as well. So there are many challenges to be highlighted about the Balkan countries. We have 43 million people. And as a matter of fact, this kind of magnitude of population is very suitable to have one proton and carbon therapy center. For example, all the other countries are covered. And about how do I use the laser pointer? Which, okay. Yeah, okay. Okay, so I still don't know how to use this. That doesn't work. Did it show me?
This one?
Up and down, I know, but laser pointer.
Yeah, this one, the light.
Okay. Okay, so let me not repeat again this slide, because people have shown this already, but we have another slide showing the population here, and it's altogether, none of the countries qualifies to have a separate center for particle therapy, but we have to join our efforts to become together and knock on the door of the European Commission and tell them that we need to build up a center for us because we deserve to be equal European citizens, to have the same opportunities for cancer treatment. These are the numbers representing the what is it called, GDP per capita, showing that we have extremely large differences in the income, and GDP per capita is a variety, a whole spectrum of values. Here we have what we have. How do we grow with the GDP per capita? This bunch of countries are growing all together, and those are non-European countries, but the European countries are up, except for Bulgaria is still sticking together with the rest of the Balkans. I mean, they don't have expected growth. What else could we say about the Balkans, about the seized countries? Is the key factor of the bad atmosphere, not a favorable atmosphere among the young population, is because they don't have a chance to establish themselves in the research society, because we are lacking facilities. And see, if we go the population with the years, we can see declining of the population. We are getting depleted of young brains, and we are here, all these curves, except for Slovenia, we are all going down. For example, for instance, North Macedonia has lost 10% of their population in the last 20 years. this is huge. I mean, okay, this is how we are in the global talent competitiveness index, which is not very favorable, except for some countries. They offer opportunities to young people to develop and to establish themselves in the scientific community. This is the cancer patient rank list. The joint characteristic for the Balkans is lung and breast cancer are leading cancers. Leading cancers 1, 2, 3, and colorectal cancer. So further, this slide was shown that the cancer grows. There are two different contributions to this growth. It is not only that the environmental and other risk factors are becoming more serious, but also it grows together with growing of diagnostic and imaging systems in the country. It will be shown in a later slide. This is all the adverse of incidence. You don't like this slide. This one was shown before. This is what we published earlier, 2 years or 3 years earlier. When was this? It is 2 years before the publication, 2018. So this is old, but probably you can follow what is going on in, what is it called, the incidence here. And the incidence, see, Germany has 740 per 100,000 a year new cancer patients. What about Albania? 2,083. From here, you can conclude this is not about the population because Albanians are not Übermensch to have less cancer than the Germans. This is just really related to the number of imaging, to the quantity of imaging facilities in the country. And here, the mortality. We on the Balkans die more than the average German or European, Western European citizen from cancer. So see, Ireland is 32 of the incident cases are dying a year. And see, the Bosnia is 2/3 are dying, 1/3 is dying in Ireland, Switzerland. So this is huge difference. This one I'm not going to show because this is a time consuming slide, but the bigger are the marbles in the slide, the more, the bigger in the radius, the more, what is it called, the more diagnostic equipment they have per 100 citizens. So, and the incidence is corresponding to okay. And another mortality to incidence ratio related to what is it called, to the GDP per capita. The poorer the country is, the mortality to incidence ratio is much higher. So see here, we have Bosnia, Albania, Serbia, Croatia, all in one circle. You can have clusters obvious for the trend. This was discussed by, already numbers were shown by Litov. Litov showed you some numbers that we can have about 4,303 eligible patients if we consider patients to be eligible to be 3% or 5%. I can't remember what was the calculation based on of the all cancers are qualifying for southern therapy, meaning deep-seated cancers and radio-resistant cancers. Their incidence in the population on the Balkans would be that one, and projected for the future would be that one. I will skip this one as well. And these are the numbers of, this is the cross-section of all those countries, how much they have in CT, in their diagnostic equipment, CT, mammo, MRI, PET, CT, gamma. It's variety of numbers, but we have comparison with the other countries. So there is, let me highlight this here. They have huge number of CTs comparable to Switzerland. But this is a new trend. The effects of this donation or whatever is the source of this would be coming later. I mean, at this point, Greece is not much advanced in cancer treatment as it should be from the early diagnostics. This is linear brachytherapy, orthovoltage and cobalt, a cross-section in the Balkans compared to, it's not compared to anything. And then we have radiation therapy region for some reference countries. See, the light blue is, they have from 1 to 2 accelerators per 1 million population, and the dark is greater than 7. So the region is diverse, but still it's dominated by light green color. And we have done some publications on the patients with cancer and countries of Southeastern Europe on the Balkans, then availability of technology for managing cancer patients. Then Southeastern European International Institutes for Sustainable Technologies also published paper. Cancer in the countries of the Balkans region, perspectives of the cancer therapy. And then I would like to come to the point where I'm going to present what do we do in North Macedonia at my university to show, to start to initiate some kind of research, because we don't have facilities. We are not related to CERN. We are not related to anything else, but we can do Monte Carlo simulations. So we have done some papers already regarding simulation on the potential shielding design. We suppose there is a shielding, and since it's going to be a green facility, meaning that we are going to go to use or reuse materials. So this is soil, spherical symmetry, imagine protection, soil and concrete. Soil and concrete, the first one, concrete. If we compare those structures, we gain different neutron spectra, and we can judge for the protection capabilities of each of them. So these are my students, and they are going to work on CEAS radiation protection projects. Okay, I'm done. Thank you.